All right, here's this bell work. We've got to write the equation of this line for this graph. And remember, the only two things that we really need on this is the slope and the y-intercept, okay? So as long as we can find those two things, then we can write this equation. So let's go ahead and start by setting this up. Y equals mx plus b. I'm just going to fill in these blanks. Remember, slope goes as the coefficient of x, and then the plus b value is the y-intercept. And like we've seen before, just visually checking for the y-intercept is very easy to do because you just got to see it. It's where this red line is going through this vertical y-axis, y number line, okay? So, I can see it's right there. And that ordered pair is right at 0, 3. Remember, your x value is always 0 there. So, all you got to do is find the y value there. And then it's positive 3, so I'm going to show it as plus 3. Then after this, all I need is the slope. Now, there's actually at least, looks like there's about 10 points to choose from on this one, but we only need one of them. And, you know, just kind of as a quick review, I'm going to use the x-intercept, which is right here. That would be at -3, 0. Okay? And yeah, for x-intercepts, the y value is always 0. Now, you could have used this point or this one. This red line is actually going through all these intersections, okay? It's not just close, it's actually right on every one of those. But it doesn't matter, you can choose whichever ones you want, okay? So I'm gonna use the slope formula, and then we'll use the stair steps as well, just to show you that it doesn't matter which one you use. So I'll start with the purple ordered pair, where the x value is 0, and then its corresponding y value there is 3. Remember, x is going in the denominator, y goes in the numerator for our slope formula. So for our purple ordered pair, the x value is 0, so I put a 0 there in the denominator. The y value is 3, so I put a 3 there in the numerator. Then I can go to the green ordered pair, which is the x-intercept. X value is -3. And remember, yeah, x values go in the denominator. Right now it's -3. And it's just minus -3. That's okay to have because the calculator will do that for us. And then its corresponding y value there is 0, and y is going in the numerator. So I'll put that y value in the numerator. Okay, now, I'm just going to plug this into the calculator. When I do, it tells me that the slope is 1. So you can put the 1 there. I believe on Canvas it wanted that to be a phantom 1, but whether you show it or not on paper, it really wouldn't matter. It's still correct. Okay, so y equals 1x plus 3 or y equals x plus 3. It's the same thing. Well, how does this become 1? Well, if you use these 2 points and use the stair step on this one, then what would have happened is you would have had to have gone up here and then to the right. It's just how far up and to the right. So in the past, we've been counting boxes, right? 1, 2, 3 boxes. So that would have been up 3. So as a slope, that would have shown as up 3, so that's positive 3, and then it's to the right 1, 2, 3 as well. And we know that that would give us a denominator of 3 also. And 3 divided by 3, anything divided by itself is 1. So we see we end up with the exact same 1 right there, okay? So you can use the stair-step method to find your slope. You can use the slope formula. And like we saw in the last unit, sometimes they're not going to give us a graph. They'll just give us the ordered pairs, and we need to be able to find the slope from 2 ordered pairs. Yeah, that was all stuff that we'd gone over last time. But here's our, looks like we had a couple objectives. I can graph equations of vertical and horizontal lines, but also we need to be able to write equations for vertical and horizontal lines. So take a minute, copy these 2 down, and we'll start on the lesson. So remember to write the linear equation of any of these lines, especially when they're straight. There's only 2 things that you need, okay? The y-intercept and the slope. Now, like we've seen before, there's a slight problem when we see vertical lines, okay? Because if we looked at an old example here, just make one up, there's the x-axis and the y-axis is your vertical lines. They're just straight up and down, okay? Now, if I drawn that better, you'd see that these two, the y-axis and this line are parallel, meaning that they will never cross or that they don't have y-intercepts. So we have to be able to write an equation for that, though. It just means that we won't be able to write it in slope-intercept form because there is no y-intercept. And actually, the slope, like we've seen, it's so large that we have to consider it undefined. And so we can't actually place a value there for slope either, okay? So it pretty much just changes the format for us. But for all other lines, we can find the slope and the y-intercept. It's only when they're straight vertical lines like that. So yeah, graph this equation, no problem. We know we can do that. And so we're just gonna put this in slope-intercept form. It's already in slope-intercept form. Now for those of you that wonder what the slope is here, because it's not actually showing the coefficient of x right here, but it's there. You just can't see it. So if you'd like to see it, it's a phantom 1, okay? So that tells us right now that the slope here is 1. Since we're graphing this equation, it'd be nice to see this as a fraction. I'll just make it over 1, which means that the slope would be, the rise is the numerator, so that's a up 1, it's positive, and then the denominator is positive as well, so that'd be to the right 1. Up 1 to the right 1, but up 1 to the right 1 from where? That's where we need that y-intercept. So remember, it's in ordered pair, and automatically the x value is 0 because it's right on the y-axis, and right here it's showing that as a +2, so that's positive 2. All right, so we got our y-axis and x-axis right there, okay? And I can put this y-intercept right now on the graph. 0, 2. So I started the origin, and I know it's right on the y-axis where the y value is 2, so I just go up 2. Boom, that's where I'm going to put my point, right here, okay? Because that's the ordered pair, 0, 2. But now I'm going to use the slope, up 1 to the right 1, in order to put, at least to find one other ordered pair. So I'd say up 1, and then to the right 1, and that would be my next ordered pair. You see, we've seen this before, but it makes a stair-step pattern. Now, before I continue, I'll just point this out because it seems like some of you had correct answers on Canvas for the last 2 assignments, but it was because you were actually putting in all the other ordered pairs on the graph. Now, I'm doing this because I'm doing it by hand, and technically you should do it, but I only have bad things to say about Canvas, so I'll try not to use too bad a language here, but it kind of sucks. Okay, so make sure when you're putting these into Canvas, you just choose the line function. You'll see it'll have like a line function up here in the top left. You just click on that, you put your 2 points like this, and then it will draw the line for you, okay? Now, like I said, since I'm doing this by hand, I'm going to continue here. I'm going to go up 1 to the right 1. That'll give me my next point. And you see how we get that those stair steps like this? And again, I'm doing it by hand, so I am going to show all the points, although on those assignments, you did not, okay? So I'll do the same thing to the left. I'm just copying those stair steps, going to the left, and it will give me these other ordered pairs. Yeah, so we fit quite a bit on there. So now that I have all the ordered pairs, all of my stair steps, I am ready now to graph the line. So let's go and do that. I'll start at the top, I guess, something like this. Yeah, it looks a little better. Put a couple arrows there, and that's nice. And again, the Canvas would have drawn that line for you if you had just chosen the first 2 points that we had, okay? Now we see a problem like this one, y equals 3. Now, we would really like this to be in slope-intercept form, like this, right? Y equals mx plus b. The problem is that it's not. Now, it's pretty close, though, right? In that equation, we got y equals 3. So we get the y equals part. And the question then would be the 3. What does it represent? Is it part of the mx? Is it part of the b? Which one is it? Because it has to be one or the other. Well, it's just a 3. It doesn't have an x with it, which means that that actually would be considered the y-intercept right there, plus 3. Okay. Well, what does this mean about our slope? It means that you could put a slope in here. It's just, since it's not showing, it'd be a phantom 0 because it's being added to your y-intercept, okay? So the slope is 0, and I can see that 0. I can actually make it 0 over whatever I want it to be. And just for convenience, I'm going to make it 0 over 10. You'll see why here in a second. Okay, so there's my slope. So 0 over 10. So I would say that's up 0. And of course, I made it the 10 positive, so that would be to the right 10. But up 0 to the right 10 from where? That's where we need that y-intercept where the x value is always 0. Just got to fill in the y value. And again, that would be in equation 3. Okay? Positive 3. So I go to my graph. We got an x-axis and a y-axis. But I got to find this ordered pair, 0, 3. So I start at the origin. It's right on the y-axis, y number line. So I go up 3, 1, 2, 3. That's where I'm going to put my point. Zero, 3. Okay, so there's my ordered pair. But then the slope says, hey, you got to go up 0, then to the right 10. So right now I've gone up 0. Now you can't see that line, but it's there. It's just not going up at all, really. And then I can go to the right 10. See that? And that would give me this ordered pair. In fact, that stair step's really easy to copy going backwards as well. So I'll just do this and put this ordered pair there as well. So the reason why this was convenient, because I didn't want to put all, I don't know, 21 points on there. And so that actually right there, what I have in red, that is the line. Okay, make this a little bit, see if I can do this decent. That's okay. I've done worse. So that's a flat line, okay? Now, if we think about this in terms of ordered pairs, the only value of y that will make this true is 3, right? And so if we go back to the original equation, y equals 3, the only value of y that will make this true is if you replace y with 3, right? The only value, which means that any ordered pair, no matter what ordered pair you have, the y value must be 3. Okay, so you could choose whatever x value you want. You can make it something really large, like 150. You could say it could be something really small, like negative 0.5. As long as your y value is 3, that's the only way that we're going to make our original equation true. So see how changing the x doesn't affect what happens in this equation? The original, you could say this one too, but certainly in the original, it doesn't have any effect. And so this is why we always end up with y values of 3. Well, that's along this horizontal line, okay? So when you see y equals just a number like this, you get a horizontal line every time. So we're going to do the same thing on this one. I'm going to take a bit of a shortcut, though, because remember, the only way to make this equation true is if we look at ordered pairs, and the y value must be negative 4. So you could say the x value is 0, which is the y-intercept, by the way. That'd be right here. So that'd be 0, negative 4, right there. Okay, so any other ordered pair will work, so long as your y value is negative 4, okay? So I could say let the x value be, I don't know, 5, okay? So 5 negative 4 would be right here. Anything else? Yeah, sure, that's so easy. Just, well, as long as you make y negative 4, this equation would have been a true statement. So you could have made this, I don't know, negative 7. Okay, so negative 7, negative 4 would be right here. Now again, I just want to emphasize the common theme here. Remember, the y values are always negative 4. Well, that's what makes this line flat right here. So let's put it on. Yeah, something like that. I'm doing that by hand. Maybe I should be using the technology. All right, how about x equals 8? Now this one certainly cannot be written in slope-intercept form, right? Because slope-intercept form is y equals mx plus b. Well, this one's x equals, so that doesn't help us. Now if there was any y in this equation, then I would say, yeah, well, that's good, but there's not, so we can't. Which means that, let's look at ordered pairs, see if this helps us. Because any ordered pair will work so long as your x value is 8. That's the only way that you're going to make this equation true, right? Is if you make x 8. So, I mean, you could start setting up lots of ordered pairs where the x value is 8. We'll just do 3, I guess. And then you can choose whatever y value you want, just trying to make them different, I guess. So I'd say probably 8, 0, there's our x-intercept. And then 8, yeah, I'll do something kind of big on there, 10. I'm trying to make them fit on the graph, and then we'll say -4. Okay, so you can kind of start by making your ordered pairs this way. And then you can put those on the graph because like we saw in 4.1, we should be able to graph ordered pairs at least. So once we get these on the graph, then we can connect the line, okay? So 8, 0, that's the x value, that's 8, right? So I'd be looking now at the x-axis where the x value is 8. So there's 0, 1, 2, 3, 4, 5, 6, 7, 8, right there. Found it. Okay, and that would be 8, 0. Well, then I said 8, 10, right? So I'd say, okay, 8 and then up 10, boom, there it is. And then I said 8, -4. So let's put that one on. 8, -4, found it. Okay, now that I got that, like I said, I am ready now to put this line on the graph. So, you know, something like this. That blue line. Hopefully that's kind of visible. So what does this mean? It means that when there is no y-intercept from the graph, it has to show as an x== equation, not a y== equation. That's why slope-intercept form will not work for straight vertical lines, okay? Because this line is exactly parallel with our y-axis right here. So yeah, this blue line is never going to have a y-intercept. Okay, and again, the slope is so steep, we can't actually quantify it. In the past, we said it's something like DNE or undefined. All right, so x = -3. Look, if you understand this, that really when you get an x= equation with a number, that you're gonna have a vertical line, that's fine. So it's a vertical line where x is -3 on the x number line. That's it. That's the x-axis, by the way. Okay, so where is that? It's right here, -3, boom, found it. Okay, that is where x is -3. Of course, this ordered pair itself would be -3, 0. But then all we're gonna do is place a vertical line at that location, okay? Boom, there it is. I think I got that okay. So there's our red line. All right, straight vertical line, boom, we made it. So now they're gonna say, well, here's a graph, now write the equation. Okay, well, if we know if it's a vertical line, then we're going to end up with some kind of x= equation, okay? Now I'll write this one out. X equals some number. Okay, so, and to figure out what that number is, all you have to do is find where the line goes through the x number line, okay, which is the x-axis, okay? So if I looked at a graph like this one, and I'm just looking at vertical lines, right? So we'll say that's our x-axis and y-axis right here. If I saw a straight vertical line, let's say right there, hey, that's not too bad for me. And it showed that the x value here was, I don't know, -7. Then I would just say, hey, look, x equals -7. That is it. All the x values on this vertical number line will be -7. They have to be in order to make this equation true. That's the only way that's going to happen. And then if it's a horizontal number line, then we know the slope is 0, which we've seen. And so we could then just write the equation as y equals, you can say 0x, but you're just looking for the y-intercept then. Okay, now this one is not vertical or horizontal, so this is kind of a review of what we've seen. So this one we are looking for slope-intercept form, okay? So make that a little bigger. And then we can set up our equation. Y equals mx plus b. Y equals mx plus b. And like I said, I would probably start with the y-intercept on this one because it's just a visual check. There it is. I found it. All I got to do is look. And that y-intercept is at, of course, the x value has to be 0, but the y value is -2. I will show that as -2. Now I just need any other ordered pair to find the slope, and I choose this one, even though there was 1, 2, 3 other points you could have chosen, okay? So we have the ordered pair at 0, -2, but now I got the green ordered pair at 1, -4. Okay, so I'm going to go for the slope using slope formula, knowing that for both ordered pairs, the x value is in the denominator, y is in the numerator, not only if it's purple, but if it's green as well, okay? So we just got to fill those in, and I can see from the purple ordered pair that the x value is 0 and the y value is -2. So put those in. X value 0 goes in the denominator, the y value is -2, it goes in the numerator. Okay, so there's my ordered pair 0, -2. But then we got the green one, where the x value is 1 and the y value is -4. So x value in the denominator, that's 1, and the y value in the numerator is -4. All I got to do at this point is plug this into my calculator, and it will tell me the slope, and when I do, it gives me -2. Okay, so that would be my slope, -2. That would be enough for this equation. But again, if you wanted to use the stair step, that would have been fine, because you would have seen here that you would have gone down 2 here, and 1, 2 boxes, and then to the right one. Okay, and that's really what -2 is. The negative cell tells you go down 2, and then you'd make it over 1. Well, that's to the right one. Okay, same thing, just done in a different method. So again, you don't have to use both methods when you're graphing these, or even writing equations, but hopefully you found one that that works for you. There we go. On this one, we got a horizontal line, okay? So I can see that this one has a y-intercept. That means that I could, if I wanted to, write this out in slope-intercept form, okay? Now, I'll do this kind of the long way, although in the future, I'm just going to take a bit of a shortcut, just like we did before. Okay, so I can set this up, y equals mx plus b. But right now, I can see that my y-intercept is right here at that purple ordered pair. That's at 0, 2. Okay, so I got a y value there that's +2, so I put in +2. All I need now is the slope. So my slope formula, there's my fraction line, 2 subtraction signs, and then I just need any other ordered pair on this graph. I'm going to use this one. I know I usually go to the right, but I'm just pointing out that you can go to the left, okay? And what's this ordered pair? Now, if we understood what we've already seen, we should know that we should expect right now the y value to be +2, right? It's just the x value here is -5. Okay, so why do we expect this value to be 2? Because it's a horizontal line. And so the y values pretty much have to match. But let's show that they will match with this equation, okay? So my slope, what is it? Remembering that the x values go in the denominators, y is in the numerator for both ordered pairs. This will give me the slope. And so for my purple ordered pair, the x value is 0 and the y value is 2. So x value in the denominator is 0, y value in the numerator is 2. Boom, there it is. And then for my green ordered pair, we got an x value that's -5 and a y value that's 2. Okay, so x value -5 in the denominator, y value 2 in the numerator. And then we just put this into the calculator. When we do, we get a value that's 0. If you got a divide by 0 error, then remember that would mean the slope is undefined. That's a vertical line. Now, we can put this in the equation, by the way, as 0. But really, to make this fully simplified, we would probably want to write this as y equals 2. Okay, and then I'd say that should be it. Now, if you've understood what we've been going over already, then you would have seen this flat line. You would have just looked for where y goes through the y-axis. Boom, y equals 2. Done. And, well, I guess we can apply it on this one. So on this one, this is a vertical line. So I know that you can't put this in slope-intercept form, which means that I have to end up with an x equals equation. What does x equal? Well, just look where this line goes through the x-axis, the x number line. Boom, I found it right there. That's at negative 2, 0. And again, I'm just really focusing, thank you, on the x value on this, which is negative 2 right there. Well, that means x would be negative 2. That is all. And so just once again to emphasize this means that the only value of x that would make this true, even the line is showing this, the only value of x that would make this true is negative 2, right? Because you had other ordered pairs here, such as this one. That would have been negative 2, negative 3. See how the x value is still negative 2? Or even way up here, that would have been negative 2, 5. But again, it's just that you see that the x value is always negative 2 because that's the only x value that would make the equation true. Now there's our objectives. I can graph equations of vertical and horizontal lines. And if it was vertical, if it's a vertical line, then we know that the equation is x equals. If it's horizontal line, then we get y equals, okay? That would be the equations, and so yeah, if they give us the equation, then we need to be able to graph them. If they give us the graph, then we need to be able to write the equations this way, okay?